And we're going to pick up where we left off yesterday. So we talked about right at the end of class yesterday, we were talking about absolute value inequalities. And just to quickly get us back to where we were, we had, if my absolute value of x is equal to 7, that's telling me that I've got really two options. Whatever's inside that absolute value was either a positive 7 or a negative 7. And then we talked about when my absolute value of x is less than 7, then that less than, I can read this as saying the distance between x and 0 is less than 7. So we're closer than 7 to 0, which means x is sort of squeezed between -7 and +7. And when I've got the absolute value of x is greater than 7, it's saying I'm more than 7 away from 0. So that more than 7 away could be in either direction. So when I have the absolute value is greater than something, I know I'm always having to break this up into two pieces so that I'm looking at either x is less than -7 or x is greater than +7. So we're sort of more extreme. Now, we didn't actually solve any of these yesterday. We kind of just talked about this. So now let's get to some actual examples. And I'm going to start off with, we've got the absolute value of 2x plus 1 is less than or equal to 7. So the first thing, I have an absolute value. So I'm already thinking about, I know we're going to have kind of two pieces to this. I have to deal with a positive and a negative. Then I'm looking at the fact that this says the absolute value part is less than something. And when it is less than something, that's when I'm going to be squeezing this between a -7 and a +7. Oops. Getting the wheels on my whiteboard. Where we go from here, we kind of have options. Now, there was a statement in the chat. This is me writing the same statement. So these are equivalent statements. This is just me writing it without the absolute value. So just like when we were solving linear inequalities, we solve it by kind of treating the inequality symbol as if it said equal, right? So we're going to kind of pretend that this said -7 is equal and 2x plus 1 is equal to 7. We can do this in two separate pieces, or we can treat it all as one big thing. And what I mean by treat it all as one big thing, if we had equal signs, we know that we have to do the same thing to both sides in order to keep the equation the same. Well, here I have kind of three pieces, right? We've got this chunk, and this chunk. And as long as I do the same thing to all three pieces, I can keep them strung together like this. So I'm going to start by subtracting 1 everywhere, which means I've got -8 is less than or equal to 2x, which is less than or equal to 6. Then, as long as I do the same thing to each three parts, we can keep rolling. So if I want to get the x by itself, I can divide everything by 2. And I've got -4 is less than or equal to x, which is less than or equal to 3. So this would be our inequality notation form of the answer. And if I wanted to write this in interval notation, the or equal to is telling me I've got brackets. And this says that X can be between -4 and 3 inclusive. Life gets a little bit more complicated in terms of solving this when we have a greater than. So looking at example 2, I've got x plus 2 is absolute value of x plus 2 is greater than 7. So because the absolute value is greater than 7, remember this is saying we've got some distance and it's more than 7. So I've got to take both outside pieces. So to get rid of the absolute value and rewrite this statement, this actually becomes 2 statements. X plus 2 is less than -7, or X plus 2 is greater than +7. These two, because I can't squeeze that together as one statement because they're separated physically on the number line, I'm just going to go ahead and solve each of them. Here, I need to subtract 2 from both sides, so I'd have x is less than -9. Or here, when I subtract 2 from both sides, I get x is greater than 5. Putting that in interval notation, that's looking like I'm going from -infinity to -9. It is not an or equal to, so I want parentheses, not brackets, union 5 to +infinity. There's a great question in the chat about why this sign had to change. And I'm going to go back to what this looks like as a drawing, but I will also say that the way that one thing that helps me to remember it one thing that helps me to remember like what's going on with the symbols and what's going on with the negatives. This isn't exactly what's going on, but it helps me to remember that I know that if I have a greater than, I have to break it up into 2 pieces. And the one that gets a negative, well, when we multiply by a negative, we flip the sign. So I just kind of keep that in my head. But here's really what's happening in terms of drawing this out. Well, absolute value of x plus 2 being greater than 7, I'm going to do the same trick that we did yesterday, and I'm going to take that x plus 2 and write it as x minus -2. Well, if I draw this on my number line, I'm going to put -2 on there. This says I'm going to move out 7 on either side. So when I move 7 in this direction, I end up at 5. And when I move 7 in this direction, I end up at -9. And then because I wanted the distance to be greater than 7, I'm talking about what's out here and what's out here. It is, by the way, totally fine for you to do these by drawing pictures. I just think it's more time consuming. Well, when I look at this, that part over there is where x is greater than 5 because it's on the right-hand side of 5. So this side is that x is greater than 5. But over here, to show that it's on that my x's are on the more extreme end, that they're on the left-hand side, I have to remember that not only did I go in the negative direction so that I had a -7, I also am now talking about the left extreme, not the right extreme, which is why this sign had to flip. Because I need my x stuff to be to the left of -7 to make sure that I'm on the outside part. So this side would look like x is less than -9. Now in terms of, oh, okay, I must have answered a question. So there's sort of this is what's happening in the background. Mechanically, when we solve this, we're sort of just going to Mechanically, when we solve this, we're just going to have to remember that when we have a greater than or a greater than or equal to, right, we're going to have two pieces that we're working with. Let's just get a couple more examples going. And I definitely think that when it's the less than, those are sort of like the easier ones, because we don't have to think as hard and remember as much. Also, the like really, okay. The good news is for those of you that are headed to the 16 or 17 series, you're just not going to have it's not going to show up very often that you're dealing with an absolute value inequality, but they do show up on the placement test, which is kind of why we're taking a minute to talk about it. And for those of you in the in the 21 series, they will show up from time to time. So good to get some practice now. Got an absolute value because it's less than 5. I know we're talking about, I want the distance to be small. So we're going to have one piece, not 2. Since I'm going to have one piece, I'm just going to take that 4a minus 3 and squeeze it between -5 and +5. So I'm going to add a 3 everywhere, plus a 3, plus a 3, plus a 3. End up with -2 is less than 4a is less than 8. And then I can divide by 4 everywhere. Fractions are our friends. -2 divided by 4, I can choose to rewrite that as -1/2. And over here, 8 divided by 4 is 2. Putting that into interval notation, I would be going from -1/2 parentheses to 2. So there's a couple of questions in the chat that I want to address. One is about compound inequalities. Sure, we can call this a compound inequality. The mathy vocabulary behind this is really not something of importance at the moment or anywhere for calculus. There's another question in the chat about just kind of general stuff about retaking the placement exam. If you have decided that you are in a major, you're not changing your major, or you're changing your major to something where you are never going to take calculus, you do not have to take the math placement exam. If you are in a major and at some point in time in the future, you're going to take calculus, my advice is to take that placement exam now while things are fresh in your brain. Because if you pass it once, you never have to go back and pass it again, right? So if you're unsure about where you're going with your major, or you're just waiting till winter to take calculus, or even waiting till spring to take calculus, I would just take the placement exam now. You've been practicing all this math stuff, just do it, get your score, and then it's sitting there in case things change up later and you do end up wanting to take calculus. Yeah, good times. Oh, and if you're taking Math 12 in the fall, you'll need a 25 on the placement exam. Some of you have that 25 already, some of you don't. So you would need to take the placement exam. If you're taking Math 12 in the fall, you'll need to take the placement exam if you're currently below a 25. Honestly, just take the placement exam. If you just take the placement exam and you happen to get the score you need for calculus, you can still take pre-calc in the fall. Nothing like will force you into taking calculus just because you got a good score. So just take it. Also, yes, if you take Math 12 and you got an A, you got 100% in Math 12. You still can't take calculus without passing the placement exam. So take the placement exam. We'll talk a little bit more about that next week and for sure the week after, because the placement exam, one of the testing windows is going to open up that last week of STEP. So you need a 25 on the placement exam to take Math 12. If you're taking workload 910 or workload 920, you're already good to go. But still take the placement exam, because if you get the score you need, you never have to take it again. And if for no other reason than just more practice taking it, you might as well. It's 90 minutes of your life. You can carve out 90 minutes somewhere to take this placement test. Back to some absolute value stuff. I think I'm on example 4. (2x plus 5), absolute value of that minus a 2 is greater than or equal to 9. And just like when we were solving equalities with absolute value, it's important to get the absolute value part by itself before we do anything else. So when I start off here, I'm going to start by adding 2 to both sides, which is going to leave me with 2x plus 5 absolute value is greater than or equal to 11. This is the place where I say, okay, I've got a greater than or equal to, which means my distance needs to be on the outsides. So on the positive side, I've got to be greater than a thing. And on the negative side, I've got to be less than a thing to make sure that I'm on the outsides. That means this splits up to say 2x plus 5 is less than or equal to negative 11, not negative 11, or 2x plus 5 is greater than or equal to positive 11, so that I make sure that I'm on both extremes. Subtract a 5, divide by a 2, life is good. Subtract a 5 is going to give me negative 16. And when I divide by 2, I'll have negative 8. Subtract a 5 is going to give me positive 6. Dividing by 2 is going to give me a 3. When we put that into interval notation, oops, this turned into an equals, and I meant to keep it a less than or equal to. So when we put this in interval notation, we've got 2 pieces. We'll join them together with that union symbol. So this says negative infinity to negative 8, and we need brackets this time because of the or equal to. Union brackets from 3 to positive infinity. Keeping an eye on the chat, but I'm not seeing stuff pop up in the chat. On to example 5. I'm looking at this and I've got absolute value is less than something. So I know I want to be closer to the middle. I want to be less than 3 away from something. When I rewrite that, I'm going to squeeze it between negative 3 and positive 3. Next up, I'm going to need to subtract 5 everywhere. When I subtract 5, I'm going to have negative 8 is less than negative 2x is less than negative 2. Now I know when I was solving inequalities before, I made a big deal about how cool it is if you just add the 2x so that it's on the positive side of things, right? And then you don't have to remember that dividing or multiplying by a negative number flips the signs. You can do that here, but it ends up being more work. Because I've got 3 pieces, it's much easier to just divide by -2 everywhere. And when we divide by -2, we're going to remember to flip the signs of the inequalities. This will become 4 is greater than x, which is greater than 1. By the way, if you had forgotten to flip the inequalities, if you made a mistake on that part, this would have come out to look like four is less than x, which is less than 1. If you actually read that out loud and get the x out of the way, 4 is less than 1. Hopefully, if you read that out loud, your brain would go, oh, something went wrong. Right? So if you get to the end of one of these and you cover the x part up and you just read the inequality, it should still make sense. 4 is greater than 1. Yes, that's true. That's just a way that you can kind of give yourself a little reality check when you're doing these. Should we do another one? Let's do one more and then we'll take a 5-minute break. So I'm looking at example 6 and example 6 has absolute value of 8y plus 3 is less than or equal to -5. And I got a question already. Or maybe it was on the previous one and I missed it.
Yeah, just really quick, is the interval notation of the last one, would it be parentheses 1, 4 parentheses?
Yes. Sorry, should have done the interval notation on that one also. Okay, fast forward back to this one. Well, this says absolute value of some stuff is less than -5. We don't need to do any work. This can't happen. Whatever's going on over here, after we take the absolute value, it's going to be a positive number or potentially 0, but we're taking the absolute value of something, so it's either 0 or a positive number. It can't be less than something negative. The other way to think about this is if we go back to the idea of absolute value saying something about distance, this would say the distance between y and some number is less than -2. Well, unless someone has like invented some kind of weird quantum hyperspace time travel thing, I don't know how our distances are going to be negative, right? So the distance between y and some number can't be less than -5. However you want to play it, this thing has no solution. On the flip side, and I'm about to change the question. This is not, well, I'm going to be lazy and not write example 7. I'm just going to change this one. I'm writing a different question. This one is always true. Subtle difference, but the only thing that I did was change the sign over here. Whatever this is always a positive number. And some positive number is going to be greater than or equal to -4.
So there doesn't have to be like a number that equals -4. It just has to be greater than or equal to.
Correct. So we read this symbol as greater or equal to. And well, if any of you are going on to take more math in a future life, this or operator means that either of these things could be true, right? So it's not that it has to be, it's not greater and equal to, it's greater or. So this is always going to be greater than, so we've got it covered. This, the answer here would be all real numbers. So pick a number, any number, type in it. I want everybody type some number in the chat, positive numbers, negative numbers, fractions, decimals. I don't care. Give me a number. I'm hoping we get some variety. Okay, we got some variety, but so far, yeah, fractions, yeah. Okay, good times. Okay, so thank you. I'm not going to do all of these because that sounds terrible, but I'll do a few of them. So if y is equal to 67 and we plug that in, I'd have 8 times 67 plus 3, and then I'd take the absolute value. I don't know what 8 times 67 is, but I told you all you could pick any number you wanted. So let's do it. 8 times 67, that's 536 plus 3. I get 539. So this says absolute value of 539. Absolute value is not going to do anything to this because it's already a positive number. So that's 539. So then this would say, is 539 greater than or equal to -4? Why, yes, it is. Let's pick another number at random from the list. -5/4. So if I stick in -5/4, I'd have 8 times -5/4. Okay, -5 times 8 would give me -40. -40 divided by 4 would be -10. So I'd have -10 plus 3. I'd get -7. Absolute value of -7 is 7. And then I'd come over here and I'd check, is 7 greater than or equal to -4? Why, yes, it is. We could play this game with every single one of the numbers that you plugged in, but no matter what number I plug in, even if it made the stuff inside the absolute value negative, as soon as I take the absolute value of it, I'm guaranteed to have something that's greater than or equal to -4. So this is true for every single value we could plug in for y. Not just positive numbers, not just negative numbers, nothing to do with 3/8, just absolutely anything at all. Y can be any number, and this will be true. Good times. It's 10:03. Let's take a 5-minute break, come back at 10:08. everyone. We will start back up. And so I am now on example 8, if you're following along on the guided notes. Got absolute value of 3x minus 2 whole thing over 5. And that is going to be greater than 1/2. I've already got the absolute value piece like by itself. Now I'm looking at the greater than or equal to part, which tells me my distance is more than. I'm going to be looking at both sides. Since my distance is more than something, I am going to end up with 3x minus 2 over 5 is less than or equal to negative 1/2, or 3x minus 2 over 5 is greater than or equal to positive 1/2. So I'm looking at both extremes. Over here, personally, I would choose to multiply both sides by 10 and get rid of the fractions. It's not our only choice. It's just my favorite choice to get rid of fractions. So the 10 divided by 5 is going to leave me with a 2 when I simplify that, and the 2 needs to get distributed in. So I'd end up with 6x minus 4 is less than or equal to, and here 10 times 1/2 would give me a 5, only it's negative. So I've got a negative 5. When I add 4 to both sides, I get 6x is less than or equal to negative 1, which makes x less than or equal to negative 1/6. Working through the right-hand side, I can multiply both of these by 10. 10 over 5, once again, that's going to leave me with a 2. So I'd end up with 2 times 3x minus 2 is greater than or equal to, and then the 10 times 2 over here would simplify to give me a 5. So that's a 1 times 5. As long as you do the correct mathematical thing when you say the phrase cross multiply, as long as this is the result, when you do the thing that you're calling cross multiply, then absolutely, we're going to end up with the same result. When I distribute this out, I've got 6x minus 4 is greater than or equal to 5. Add 4 to both sides. 6x is greater than or equal to 9. Divide both sides by 6. And I'm going to take the extra second here. It's totally fine to leave this as 9 divided by 6, unless the problem has somehow stated that we need this to be in lowest terms. 9 and 6 are both divisible by 3, which means this can also be written as 3/2. So when I put my final form together here, x is less than or equal to negative 1/6, means I'm on that outside from negative infinity to negative 1/6. Union, and then I'm looking at x is greater than 3/2, so I need a 3/2 to positive infinity, and I have caught my mistake. Anyone else see the mistake I just made?
Should be brackets.
Totally. So let's switch those up, and that is looking good to me. If you're following along on the guided notes, the next part of this is really just to practice carefully reading the instructions and taking a minute to actually read what the instructions say. So I'm going to go ahead and I was trying to decide if I wanted to write these out or switch over to the document camera for a second. I think I'm going to switch to the doc cam for a second. And write on my paper. So. It'll come into focus. Give me just a second. I think it'll come into focus. Has this cool autofocus button. It pretends like it's going to do something. There we go. Okay. So when the question is stating that we need to evaluate, this usually means that we're going to be plugging in a number. So evaluate the absolute value of 5x plus 3 when x equals 0 is telling us, hey, go plug in 0 for x. And that's going to make this absolute value of 5 times 0 plus 3. 5 times 0 is 0. When we add a 3, we get 3. So that's absolute value of 3 or just 3. If we're being asked to solve, then I know my final answer should be like x equals something. So if I'm solving an absolute value, I know we're going to have to solve for both the stuff inside being equal to a -7 and the stuff inside being equal to a +7. So I'm going to have 5x plus 3 is equal to -7. And we're going to have 5x plus 3 is equal to +7. I did not leave myself enough room to work here. That's okay. If 5x plus 3 is equal to -7, I can subtract 3 from both sides, which should give me a -10. And when I divide by 5, that's going to mean that x is equal to -2. Over here, if I subtract 3 from both sides, let's put my -2 over here. If I subtract 3 from both sides, then I'll have a 4. And if 5x is equal to 4, then x would be 4/5. If I look at part C, is 0 a solution to this? So is 0 a solution means my answer is going to be yes or no. And I've got to figure out which one it is. Is it a solution? Is it not a solution? We're going to test that by plugging in 0. Now, we've already evaluated this for plugging in 0 because that was part A. So if we plug in 0, we'd end up with really asking the question, is 3 greater than 7? And the answer to that is no. So it is not a solution to this. 3 is not bigger than 7. Again, this bottom one is asking us to solve something. So I know this one is back to some kind of answer that's going to involve x. Because it's an absolute value and greater than, I know we're talking about what's on the outsides. So I'm going to push this out and say 5x plus 3 is less than or equal to, sorry, just less than, there was no equal to, less than -7, or 5x plus 3 is greater than +7. Subtracting a 3 from both sides and then dividing by 5, I've got x is less than -2. Subtracting a 3 from both sides, dividing by 5, I've got x is greater than 4/5. If we put this one into interval notation, I know the part over here is telling me -infinity to -2, and I'm going to make a union with the 4/5 to +infinity. Pausing there just for a second. Because I'm going to switch the camera back, which means that stuff will be gone. So I'm checking, keeping an eye on the chat. Okay, I'm gonna switch my video back. And we've got about 25 minutes left. And I have some different things that we can do. We can definitely get started on some graphing and function stuff, but I wanted to first check and see if there are any homework questions that anyone would really love for me to go over. And you can put something in the chat if you've got something in mind. I'm pulling up the homework right now so that I've got it open in case people wanted to just give me question numbers. And if there aren't questions from the homework, that's fine too. Okay, let's see. Oh, are the guided notes locked? Sorry. Yes, absolutely. I will unlock the guided notes. I didn't realize guided notes were locked. Oh, for next week. Got it. Yes. Okay. Yes, I can unlock next week's guided notes for sure. But I wasn't actually going to necessarily jump into next week's guided notes. I'm also happy to do questions from the practice quiz. And since I am oh, so there's a question in the chat that I do want to address. So let me switch back to the doc cam for a second. Sorry. So the question on the last one is essentially, would it have been okay to put this all as one thing, not as two? And the answer is no. Because I read this as we have some sort of distance is more than 7, that's automatically telling me that this has to be split up into 2 pieces if we're going to be more than 7 away from something. Now, if we had just left it like this and squeezed it between -7 and 7, we might have ended up with something that looked like, and let me just make sure that this one doesn't work. -2 is greater than x, which is greater than 4/5. So if we do the same kind of reality check as I was suggesting on the other one, if you cover up the x part, does the statement make sense? And it does not. -2 is not greater than 4/5. So it's definitely a good way to check when you have these inequalities. If you cover up the x, do the numbers still make sense? And they don't. So that's the only way we should be thinking about this problem because of the greater than. Oh, sorry, because of the greater than. Okay. I want to take a look at one of the problems from the practice quiz, which is posted. And I want to take a look at it because it's a word problem. So I am looking at the practice problems for quiz 3 and I'm, you know what? What if I just put it in the chat? Then I don't have to write this whole thing out on the board. That is quite silly of me. Okay. Oh, so there's a question in the chat around like when you're doing your written homework, should you box the interval notation or box the version that's got like X's and greater thans or equal tos? I don't actually care. They're both right. They're both equivalent forms, but I think all the quizzes are set to ask for the interval notation. So make sure that you do write your answers in interval notation so that it'll be faster when you're filling out the homework quiz. Okay, so I popped in the chat. The length of a rectangle is 5 times its width. If the perimeter of the rectangle is to be at least 120 inches, what are the possible values for the width? Which brings me to, there are some geometric formulas that you are expected to have memorized and that will show up often enough in calculus that it is important to have them memorized. So let's talk about some plane geometry formulas. And there will be no sines, cosines, or tangents in here. I'm talking about shapes, okay? So we're talking about geometry formulas of shapes. Oops. So the first one that shows up pretty often, I'm talking about a rectangle. When we think about rectangles, a couple of things that we might need to know are the perimeter and the area. There are lots of different ways that I could label this rectangle. I could label it X and Y, A and B, the height and the base, the length and the width. Doesn't matter. Just pick something. So typically when I think about a rectangle, I choose to think about it as a base and a height. So I think about the length of this side as the height and the length of this side as the base. It's totally fine to think about them as length and width. And that's often how problems are written. I just always look at that and I'm like, I don't know which one I'm supposed to call the length and which one I'm supposed to call the width. For me, height and base are more clear. I think it's more standard, maybe, to call this side the width and this side the length. But they're just arbitrary choices of letters. But when we talk about the perimeter, that's the distance all the way around the object. So for a rectangle, that perimeter, if we're using length and width, would look like a length plus a width plus another length plus another width. So the perimeter for this rectangle, if we're using length and width, I could write this as my perimeter is equal to twice the length plus twice the width. Or if we're using base and height, I could call that twice the base plus twice the height. For the area of a rectangle, I think of my area as a base times height. But it's also totally fine to think about the area as a length times a width. One of the shapes that I know you've been talking about a lot in Math C, triangles, but I told you I'm not going to put sines and cosines in here unless you want to, and then we can practice that also. But for any triangle, or let me start with a right triangle. So a right triangle means that one of the angles in the triangle is 90 degrees. So if I have a right triangle specifically, then we get this extra formula we usually call the Pythagorean Theorem, but I'll be honest, most people just say what the formula is. A squared plus B squared equals C squared. So for a right triangle, that's true. For any triangle at all, when we go to find the area formula for a triangle is 1/2 the base times the height. And for any triangle at all, the perimeter always means we're adding up the distance around the object. So for the way that I've labeled this thing, my perimeter would look like A plus B plus C. Now there's another thing that's true about any triangle, and that's that the interior angles all add up to 180 degrees, or they all add up to pi. I'm not going to add that on here, but it's just another fun fact about any sort of triangle. Cool. Rectangles, triangles, and the last shape I want to bring up are circles. I don't think I have space on here to put my circle in, so I'm going to have to erase my rectangle for it. When we talk about circles, everything really relates back to the radius. The radius is the distance from the center of the circle to the outside of the circle. We have a different word for perimeter when we're talking about circles, but it's the same idea. So perimeter turns into circumference when we're talking about circles. And the circumference is equal to 2 pi times the radius. The area for a circle is equal to pi times the radius squared. And all of those formulas are things that you should know and have memorized. They come up often enough. All of that said, now let's zoom back into the specific word problem from the practice quiz. I didn't see any questions come up from this because, well, they're formulas. I don't know. So we've got this word problem. I see words. I don't freak out. I find the question mark and I work backwards in the clause until I find the question word. Got that question mark with the for values possible, the are what. I finally found a question word. What are the possible values for the width? So the thing we're trying to figure out is values for the width. So we're looking for, want to find what the heck is the width. Now I'm looking for other statements in the problem that are going to help me piece together the puzzle to figure out the width. I'm now going to fast forward to the beginning of the question and read through it. The length of a rectangle is 5 times its width. Well, that I can already start to write a mathematical expression for. So the length means we're going to write an equal sign, 5 times the width. So 5 times the width. And if I turn those into letters, I could say the length is equal to 5W. Okay, helpful, but that's not enough information yet to find the width. The next statement says the perimeter of the rectangle is to be at least 120 inches. So now we're bringing in perimeter. I know what the equation for perimeter is. That's going to look like 2W plus 2L. And then it says at least 120 inches. So I'm going to do something with the 120. And the phrase at least means this should be greater than or equal to. if it said at, so this is coming from the at least 120. If it had said at most 120, this would have been a less than or equal to. Putting this together, I'm going to look at this and say, oh, we finally have some kind of equation-y thing. But what I'm trying to find is the width. So I have to get rid of the length. And I can get rid of the length by replacing it with 5W. So I can treat this as a 2W plus 2 times the 5W is greater than or equal to 120. Distribute my 5, 2W plus 10W is greater than or equal to 120. 12W is greater than or equal to 120. So W is greater than or equal to 10. So this is going to be true as long as the width is greater than or equal to 10 inches. Oh, not with, how about with, missing a letter. Questions about any of that? Not seeing questions, good times. Okay. So we have 10 minutes left. I'm not really going to dive into the guided notes about graphing just yet. What I am going to do is some real quick review, and I'm sure, well, hopefully this lines up with stuff that you either saw in Math C, but I'll take a question from Nye first. Yeah.
Oh, I just had a quick question. For one of the, like, I'm getting a little confused on when you said like the absolute value and it's like less than or greater than to a negative number.
Sure.
You said, because I'm trying, so the problem I'm on right now, it's like the absolute value of A plus 2 is greater than or equal to -5.
Is the +2 inside the absolute value or no?
Yeah.
Okay, so absolute value of A plus 2 is greater than or equal to -5.
Yeah. This
Well,
is,
I don't have to do any work.
yeah, right? No solution.
Yeah,
Okay.
or it's always true.
Yeah. Yeah, because I was like, even if it equals -5, like it can't like be equal to -5. Like plugging in -5 just wouldn't work.
So this whole side, doesn't matter what I plug in for A, is always positive. If it's a positive number, it is greater than or equal to -5. This has all real numbers as a solution. Yeah, I know it feels a little confusing. Practice. If I had absolute value of some stuff, is less than 0. This thing has no solutions. Doesn't matter what the stuff is in there, the absolute value of it is not going to be negative. But if I had absolute value of some junk, is greater than -2. This would be all real numbers. Because whatever the junk is, the absolute value of it is bigger than -2. I don't know if that helps, but sometimes kind of taking the actual equation part out of it is useful. Yeah. And there's another question in the chat about, will there be a word problem on the quiz? Absolutely, there will be a word problem on the quiz. Thanks for asking. No, you shouldn't be crying from the word problems. You should think we speak in words every day. Isn't it cool that I get to do math in words too? Because we're really good at saying words. We kind of been practicing that since, I don't know, okay, like since you were a year-ish old, you were saying some words. By the time you were 2, you were probably saying lots of words. So you've been using words for a long time. So getting to do math in words, you should be like, yeah, I get to do math in words. Let's see, other questions. The quiz will open up in 5 minutes. The quiz is set to open up always Thursdays before class, or I mean, right after class. Yeah. Good times. Okay.
Would you have time to like go over another word problem? Because looking at the practice problems for quiz 3, I'm like, oh, that's the word problem we're all talking about.
Yeah, that's one we just did. I pulled it from the practice problems from quiz 3. Yeah.
Oh, got it. Okay.
Yeah. Do you want me to pull another one from the book?
Sure. Yeah.
Okay. Give me a second. Loading. And I know I've said this a few times, but the book really does have lots of great practice problems. So I'm not super clever about writing word problems, so, you know, let me find something better than what I just found. It was not great. Here we go. Okay, so in case you wanted to follow along in the book, this is on page 234. I chose problem 101. Just because I can. So I'm going to put it in the chat. Not a geometry one, but it is a practicing with inequalities kind of thing. So the sum of 2 consecutive integers is at least 583. What are the possibilities for the first of the 2 integers? I see words, I find the question mark, I move backwards until I hit the question word. Integers to the of first, the for possibilities, the are what, we found a question word. What are the possibilities for the first of the 2 integers? So the thing I'm trying to find is the first of the two integers. Okay, now I get to go back up to the beginning. And by the way, it copied a little bit weird, but whatever. So I'm going to go back up to the beginning. Consecutive integers, the sum of two consecutive integers is at least 583. So I've got the sum of two integers. Sum means we're going to be adding two things. So I don't know what to call the integers. I'm going to go ahead and just think about them as like X and Y. These are going to be my two numbers. So the sum of those integers would look like X plus Y. And we know that that's at least 583. Well, at least means that this thing has to be greater than or equal to 583. Now, for the consecutive part. So this alone isn't super helpful, right? I can call this the first and this one the second, so that I know I'm trying to solve for X, but this Y is in the way, so I kind of need more information. And the fact that it says consecutive is the information that we needed. So consecutive integers would be like 15, 16, 31, 32, 79, 80. Consecutive integers are integers that follow each other, right? So if the first number is 15, the next integer would be the 15 plus 1. So I don't know what the integer is, but I know that the second integer would actually be X plus 1. So I'm going to replace this statement by saying X plus 1 has to be greater than or equal to 583. Y'all got it from there for sure. But that's what it means by consecutive. It is 10:46. I'm going to stop the recording.